Hello everyone, today in this video we are going to talk about vectors, and after watching this video you should be able to define vectors, calculate the magnitude of a vector, find the unit vector and add and subtract vectors. So let's understand the vector by a real life example. Suppose you are standing somewhere out here and you have been given two instructions. One, walk 5 meters, and another instruction is walk 5 meters towards the north. So what is the difference between the two instructions? So in first case you can walk 5 meters in any direction, but out here you have to walk in a specific direction, that is towards the north. So out here we have numbers only, magnitude, and out here we have a magnitude and direction. So any quantity which has both magnitude and direction, we call them vectors. So but in higher class we have to add one more condition for the vectors. So vector is any physical quantity which has both magnitude and direction, and they have to follow law of vector addition. Some examples of vectors are velocity, displacement, acceleration, force, momentum, etc. The reason that we have added the second condition out here is there are some quantities which has both magnitude and direction, like current, but they are not vectors because they do not follow law of vector addition, and we will discuss the law of vector addition afterwards. So we represent the vector by arrowhead. The point from where the vector start is called tail, and where it ends is called head, and the length of the vector represent the magnitude of the vector, and this arrowhead shows the direction of vector. If you want to write vector A, then you will write A, on top of that we will put arrow, so that A arrow means vector A. Similarly, if you want to write vector B, you will write B, on top of that we will write arrow. So now let's represent a vector in mathematical form. So to do that we make use of position vector. So position vector of an object is a straight line between origin and the position of that object. So suppose this is xyz coordinate, and we have one object, and this is the shadow of the object, and the straight line between the origin and the object is called position vector, and we denote it by A. And if you want to reach this point, then you have to cover the distance ax towards x, then you have to come distance az towards z direction, and you have to cover ay distance in the direction of y axis, then you will reach this point. So now to represent A, I can write ax towards the direction of x plus ay y plus az z. Now we'll change this diagram little bit. So this is the direction towards x, this is the direction towards z, and this is the direction towards y. So now I'll represent the direction towards x axis by I cap. I cap is the unit vector along x axis. Similarly, I can represent direction towards y with j cap. Similarly, we represent the direction towards z axis by a unit vector k cap. So now I can write this expression in the form of vector by a vector is equal to ax I cap plus ay j cap plus az k cap. And now I'll take one example of a vector. Out here a vector is 5i plus 3j minus 2k. So out here ax is 5, ay is 3, and az is minus 2. As we all know, force is a vector, so we can represent force in a form of vector. So out here you can see force is given by 4i minus 3j minus 0k. Magnitude of a vector. Magnitude of a vector is the distance between initial point and the end point of the vector. So out here this line is the magnitude. So the symbol for magnitude is either we write vector A inside the modulus, or we can just write capital A without the cap. Suppose this is a vector A, and we have to find the magnitude of vector A. So the magnitude will be given by this, or simply by A is equal to root over ax square plus ay square plus az square. So let's take an example. Suppose this is the force and I want to find the magnitude of this force. So the magnitude of this force will be given by fx square plus fy square plus fz square. So fx is 4, fy is 3 and fz is 0. So I'll put the value, and 4 square is 16, 3 square is 9. We'll get force to be root over 25 or 5 Newton. So out here you can see we just got the number and we don't have direction out here. So this is the magnitude of this force. Next is unit vector. So unit vector is a vector that has magnitude of 1 and it is also known as direction vector, and it is represented by this cap. So unit vector of A is given by A cap, and that will be is equal to vector by the magnitude, and we know vector is A vector and magnitude is just A. So this is the formula for unit vector. So let's find the unit vector for this. So in order to find the unit vector we need the magnitude. So the magnitude is given by root over ax square, that is 5 square, ay square, that is 3 square, and az square, that is minus 2 square. So we don't need to write negative because of this square, it will automatically become positive. So if you solve this you will get root over 38 to be the magnitude of this vector. Now unit vector is given by vector by magnitude, and the vector is 5i plus 3j minus 2k, and the magnitude is root over 38. Now you can further simplify this. So this is the unit vector of this A vector. So addition of two vector. So suppose this is vector A and suppose this is vector B. So when we add two vector we just add the like terms. So ax plus bxi plus ay plus byj plus az plus bzk. So let's take an example. So a plus b is 5 plus 2i plus 3 minus 1j plus minus 2 plus 3k. So when you solve this you will get this. And now you can further find the magnitude of a plus b. So the magnitude of a plus b will be given by root over 7 square plus 2 square plus 1 square. So this is root over 54 and root over 54 or 3 root 6. Now subtraction of two vector. So in subtraction also we subtract the like terms. So a minus b will be given by 5 minus 2i plus 3 minus of minus 1j plus minus 2 minus 3k. So when you solve this you will get this, and if you want to find the magnitude you can find the magnitude as root over 3 square plus 4 square plus 5 square, that is 9 plus 16 plus 25 root over 50 or 5 root 2 is the magnitude of a minus b. So now let's solve one question. Find a vector having magnitude equal to that of A and parallel to B. So we have to find one vector whose magnitude is equal to the magnitude of A and whose direction is towards the B. So our required vector is vector with magnitude of A and direction of B. Direction of B means unit vector along B. So first I will find the magnitude of A. Magnitude of A is given by root over 7 square plus 4 square plus 4 square. This will come as 9, and now we have to find the unit vector of. So magnitude of B is given by root over 6 square minus 2 square plus 3 square, that will come as 7. Unit vector along B is given by B vector by magnitude of B. So this is the B vector, 6i minus 2j plus 3k, and magnitude is 7. Now our required vector is given by magnitude of A into unit vector of B. So magnitude of A is 9 and unit vector of B is this. So when you multiply this you will get your vector. So similarly you can try this question. So two vectors are given by this. You have to find magnitude of A and magnitude of B. You have to find the unit vector along A and unit vector along B, and A plus B, A minus B, magnitude of A plus B, magnitude of A minus B, unit vector along b minus a. So for this you consider b minus a to be c vector and you will find the unit vector of c, and you have to find the vector which has the magnitude equal to b and is parallel to a. So that this question is similar to the question that we have done before. So the last question, on adding a vector with a vector gives unit vector along x-axis, find the vector. So we are adding one vector to this vector and as a result we are getting unit vector along x, that is I. So we can write this is a plus, suppose the required vector is c, then the resultant will be I, that is unit vector along x. So if you solve this you can find the vector c easily. So this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.